Good day, everyone. Today we have an exciting topic to explore Planck's quantum hypothesis. Before we dive into the details, let us have and establish our learning objectives for today. Okay, at the end of the lesson, the student should be able to A. Understand Planck's quantum hypothesis and its significance in quantum mechanics. B. Appreciate the historical context and impact of Planck's quantum hypothesis on scientific understanding. And C. Apply the E equals hf formula to solve energy quantization problems in Planck's quantum hypothesis. Max Planck is a German physicist born in 1858. Formulating a quantum hypothesis, he introduced the concept of energy quantization and the of discrete units called quanta. Planck's work revolutionized our understanding of energy and laid the groundwork for quantum theory. He is awarded the Nobel Prize in Physics in 1918 for his contribution to the quantum theory. His work revolutionized our understanding of energy and paved the way of advancement in physics and technology. Max Planck, the German physicist, was awarded the Nobel Prize in Physics in 1918. And for his groundbreaking contributions to the quantum theory, his work revolutionized our understanding of energy by introducing the concept of energy quantization and the notion of quanta. So Planck's remarkable discoveries paved the significant advancement in physics and technology, shaping the modern world as we know it. And now, let us know and understand the Planck's quantum hypothesis. Proposed that energy is quantized, meaning it exists in discrete units called quanta. Planck's quantum hypothesis proposed that energy is not continuous but exists in discrete units called quanta. This means that energy can only exist in a specific rather than being infinitely divisible. This challenges the classical views of energy as continuous and explains the behavior of particles at the microscopic level. This concept challenged the classical view of energy as continuous and explained various phenomena at the microscopic level. It provided a new understanding of the behavior of particles such as electrons and laid foundation for the development of quantum mechanics. So, Planck introduced the Planck's constant, which is h, a fundamental constant of nature. So the Planck's constant relates the energy of a quantum to its frequency and has a value of approximately 6.26 times 10 negative 24 joules per second. So it quantifies the relationship between the energy and frequency, and it is crucial in understanding the behavior of quantum systems. Perception of Planck constant and its significance. As part of his quantum hypothesis, Planck introduced the Planck's constant, which is h. The Planck constant is a fundamental constant of the nature that relates the energy of a quantum to its frequency. So it quantifies the related energy and the frequency, providing a mathematical framework to understand the quantum systems. So the value of Planck constant, approximately 6.626 times 10 raised to the power of joules second, is crucial factor in calculation and measurement involving the quantum phenomena. To calculate the energy of a quantum, given the frequency, you can use the E is equals to hf, where E represents the energy of the quantum, and h is the Planck constant, and f is the frequency of the quantum. So let's simplify. So simply multiply of the Planck constant, which is h, by the frequency of f to obtain the energy of E of the quantum. So for example, if the frequency of a quantum is 5 times 10 raised to the power of 14 Hertz and the Planck constant is approximately 6.26 10 raised to the power of negative joules, negative 34 joules per second. So you can calculate the energy as follows. So E is equals to the quantity of 6.626 times 10 raised to the power of negative 14 joules per second times the 5 times 10 raised to the power of 14 hertz is equals to 313 times 10 raised to the power of negative 19 joules. So therefore, the energy of the quantity, the frequency of 5 times 10 raised to the power of 14 hertz is approximately 3.313 times 10 raised to the power of negative 19 joules. So the ultraviolet catastrophe refers to the failure of classical physics to explain the distribution of energy in bloody radiation. So the ultraviolet catastrophe refers to the failure of classical physics to explain the distribution of the energy in the black body radiation. It means that in classical physics, it was predicted that the energy emitted by a black body would increase infinitely as the frequency of radiation approached to the ultraviolet range. However, experimental observation did not align with this prediction, leading to term ultraviolet catastrophe to describe this discrepancy. This problem highlighted a significant limitation in classical physics and the need for a new understanding of energy distribution. Next, Planck proposed that energy is quantized, meaning it exists in discrete units called quanta. This means that the energy can only exist in a specific amounts rather than being infinitely divisible. So, this challenges the classical view of energy as continuous and explain the behavior of particles at a microscopic level. This means okay. This concept is challenge the classical views of energy as continuous and explain the various phenomena at the microscopic level. So it provides a new understanding of the behavior of particles such as electrons and lead the function of the development of quantum mechanics. Planck introduced the Planck constant, which is h, a fundamental constant of nature, and the Planck constant relates the energy of quantum to its frequency and has a value of approximately 6.626 times 10 raised to the power of negative 34 joules seconds. It quantifies the relationship between the energy and frequency, and it's crucial in understanding the behavior of quantum system. Planck quantum hypothesis successfully resolved the problem by introducing the energy quantization. Planck's quantum hypothesis is successfully again by introducing the energy quantization. So Max Planck proposed that the energy is quantized, meaning it exists in discrete units called quanta. So the energy quantization provides a solution to the ultraviolet catastrophe by addressing the incorrect prediction of classical physics. By considering the energy as quantized, Planck theory accurately predicted distribution of energy and explained the observed data. So, by considering the energy as quantized, Planck theory accurately predicted the distribution of energy. So, Planck's quantum hypothesis provides a mathematical formula that accurately describes the distribution of energy in the black body radiation. So, the concept of energy quantization allowed for the calculation in this level. So this accurate prediction of energy distribution resolved the ultraviolet catastrophe and aligned with the experimental observation. So next is the impact of physics and development of quantum mechanics. And so first is the Planck quantum hypothesis revolutionized physics. Planck's quantum hypothesis brought about the revolutionary shape of our understanding of energy and laid the foundation of the development of quantum mechanics. So this development of quantum mechanics are the Planck's quantum hypothesis paved the way of the development of quantum mechanics, which is a branch of a physics that describes the behavior of matter and energy on the smallest scales. The introduction of a key concept is quantum mechanics introduced groundbreaking concepts such as wave-particle duality and uncertainty. fundamentally transforming our understanding of microscopic world and behavior of particles. So it does have an examples of application in various fields. So first is quantum mechanics has practical applications in technology, medicine, and telecommunication. So quantum computers or quantum encryption and MRI are example of quantum-based technology. So quantum mechanics has diverse application. First is technology, quantum computers and encryption enhance computing power and data security. And for the medicine, it is a quantum principle improve a medical imaging and contribute the precision the medicines. Next is the telecommunications, which is the quantum encryption ensures the secure communication. To sum it up, Planck's quantum hypothesis proposed by Max Planck in 1900s to address the ultraviolet catastrophe in classical physics. He introduced the concept of energy quantization where the energy exists in discrete units called quanta. So Planck's constant, which is h, relates the energy of quantum to its frequency, which is Ex equals to hf, and resolve the ultraviolet catastrophe by accurately predicting the distribution of energy in blackbody radiation. The lead foundation for quantum mechanics and its principle like wave particle duality and certainty. Then application include quantum computing, quantum cryptography, and medical imaging. Significantly impacted physics by revolutionizing our understanding of energy and practical of behavior. That's all. Thank you.